Hello students, welcome to Smarter Engineer. Hope you are doing well. Today our topic is encoding and decoding, which is very much important because in my next class I am going to solve some problems regarding encoding, decoding and including all the syllabus. So this is very much important and for your semester also. In our previous class we have discussed different kind of animation techniques, and now from today we'll learn some different kind of encoding and decoding schema. We have to know, so what is encoding, what is decoding, what is the use of this encoding and decoding. We'll learn these topics. So what is encoding? At first, what is encoding? Encoding involves the converting data from its original form into another form for transmission. Okay, I am coming to decoding portion in my next or after that slide. But what is encoding? Encoding is used for secure transmission of data in computer technology to one form to another form. Given sequence of character, alphabet, symbols, like that. In electronics, encoding refers to analog to digital conversion. It is also used in context of image, video, text or multimedia. You know that we'll use this in our multimedia, and multimedia consists of always text, audio, video, graphics and animation. So we will use this encoding or decoding schema in our multimedia using text, audio, video, graphics, animation, etc. Clear? Now, what is digital conversion? It is also used in the context of image, video, text, multimedia, etc. So, what is encoding? Encoding is the process of using the patterns of the voltage or current, okay, induced into represent ones and zeros at the time of digital signals. Whenever it comes to digital signal, it always represents as 1 or 0, but whenever it comes to analog signal, then it is a continuous form. In our previous lecture we have seen it that it looks like a continuous waveform in the analog section. Whenever we are converting this into digital section, then it converts into 0 and 1. Like this, analog data is represented by using continuous variable physical quantity such as voltage. Voltage is an analog signal. So analog signal looks like this. We have also seen this in my previous class. How does it look like? For an example, suppose take an example. A watch, your wristwatch, that displays the time by hands moving smoothly around the clock face is an analog device. So this is a good example of analog device. Most natural events in the real world such as temperature, light, pressure are in analog form because they are continuous, not discrete. And digital data is represented by this kind of digital clock example, or nowadays you can see the digital watch, or you can say smart band on your hand. So that's a good example of digital watch which represent actually digital data. And nowadays we in computer science or information technology, we work with data, and data are always in digital form. Whenever we are working with data, for data science, machine learning, deep learning, big data, data mining, the data are always in digital form, not in continuous or analog form. They are always in digital form. And digital signals are represented as this. I have also discussed this digital signals representation and also draw in my previous lecture. I will give the link in the description box below. Don't worry. But it looks like this. So what we need, what is the actual need of this encoding? Program compiling and execution. Okay, so the main needs of encoding is program compiling and execution. Number 2, transmission, storage and compression or decompression. If we have storage problem, suppose we compress the data, a big data compressed in a smaller version, smaller portion, then our storage space required must be minimal. So this is a good advantage. And whenever we want, we can decompress it also. So this is a good example where we can use the compression or encoding. Application data processing such as file conversion, we also need encoding whenever we need file conversion. Suppose NTFS to FAT file conversion or PNG to JPEG. I have already discussed what is lossless and lossy compression, right? So now you know what is lossless and what is lossy. So if you convert from lossless to lossy, then your data must be minimal. Now come to the next slide. The form of the data, either analog or digital, and the transmission signal, either analog or digital signal. So the form of the data, either analog or digital, and the transmission signal, either analog or digital signal, affects the quality of the data received and the cost of the transmission. Okay, so come to the next slide. The quality of analog data depends on maintaining the exact wave as it moves through a wire or space. If it is corrupted in any way, there is no way of regenerating the wave. As it is continuous wave signal, so you have to maintain the continuity if it is going through a wire or space. If it is corrupted in any way, there is no way of regenerating the wave. But in case of discrete form, however, or digital data is transmitted as a series of 0 and 1, and it is possible to regenerate data that has been corrupted. We can regenerate the data in case of digital form. So what is decoding? Decoding is the just opposite process of the encoding. Okay, the conversion of an encoded format back to its original format, that is decoding. If we convert or converts encoded form into a decoded form or back to its original form, then this is called decoding. However, digital data is transmitted as 0 and 1, so that is to reconstruct the data, it is only necessary to distinguish between 0 and 1. So this is much more easier to get back. But in case of analog signal, if the continuity is broken, then it is compromised. There are 4 encoding and decoding possibility in transmission. What are these? Analog to analog, digital to analog, digital to digital, and analog to digital signal. Analog analog, digital, and analog to digital. These are the four. Now you can see encoding and transmission choice. Analog data, analog signal. Suppose telephone, analog digital codec. Codec means, what is the meaning of codec? Coding, encoding. Okay. So digital to analog. And modem, modulation, demodulation, digital transmitter. So these are the data source, can be analog or digital. You can choose anything. Encoding and transmission choices. Transmission can be analog or digital. Analog data to analog signal. The wave shape of the data is encoded into signal. A telephone encodes analog data in the form of sounds into analog signals suitable for the telephone line. If the signal is corrupted, there is no way of restoring the original analog data. Suppose you are calling over phone. If your line is disturbed, if your wire is disturbed, then you can't get heard, or you can't even hear from other side, because the analog signal or continuity is already broken or compromised, and you can't restore that at that moment. Digital data to analog signal. A series of zeros and one is encoded into a continuous wave. A modem encodes or modulates actually digital data from a computer into analog signal for the telephone line. When the analog signal is received by another modem, it decodes or demodulate. So modem actually what actually does, modulate and demodulate the analog signal into digital data. So modem helps us like this. You can see how actually modem encodes the digital data from computer, digital signal through modem, analog signal, and then phone line, modem, again digital signal to computer. So you can see this is a very good example or picture. This is visible, right? I think yes. A modem encodes digital data to analog signal and decodes analog signal to digital data. Analog data to digital signal, the wave shape of the data is encoded into a series of 0 and 1. This process of generating digit or number is called digitizing. I have already discussed what is digitizing in my previous lecture. Still, what is digitizing? Process of generating digit or number is called digitizing. Images are digitized using such devices such as scanner. Sounds are digitized in such a process called sampling. I have already discussed what is sampling, quantization, etc. So this is a good example, good picture. You can see how sound card actually find the 0, 1 value. Okay. Now, what are the use of encoding and decoding? Where we can use it? Encoding and decoding. Actually, encoding and decoding are used in data communication, networking, storage, radio communication system, etc. Radio communication system is very much important for encoding and decoding. Encoding and decoding are also used in the process of analog to digital conversion and digital to analog conversion, that is AD conversion and DA conversion, text, image, video, or multimedia concept. Everywhere is used. Okay, so we have learned today what is encoding, what is decoding, how can we use this, what is the need of encoding and decoding, and what are the analog and digital signals are, and a much more example where actually we are using encoding, decoding, or analog or digital or continuous and discrete, and how can we convert this all. So I think this is all about today's lecture series. In my next lecture series I will discuss about some encoding decoding schemas like Lempel-Ziv encoding, Huffman encoding technique, RLE, run length encoding, etc., and obviously with problem solution. That's it. If you have any question, any query, please feel free to ask me in the comment section below or mail me. And if you like the video, please subscribe our channel, share with your friends, and press the bell notification on to get the instant notification. Thank you. Bye bye.